All right, everyone, homework last night, page 553. We had questions 1 and 3 to 9. Any issues with 1 or any of those in that group of 3 to 9? 9B? 9B, I heard again. 9B, 9B, and 9B seems to be the common thread here. Oh, yes. Oh, that's one of those ones where, like, it's almost like that one you did with the sub that day in class, and then you said, the next day when I came back, you said, is it really as hard as he made it out to be? And I said, yes. It's almost like that, eh? All right, let's copy this over so we have a little bit more space here to work. It says a negative charge of 3 millicoulombs is 1.2 meters to the right of another one that has a negative charge of 2 millicoulombs. And we want to find the point along the same line between the two charges where the net electric field equals 0. All right, so let's draw this out here. We've got negative, we'll call that charge number 1. We've got negative 3.00 times 10 to the minus 3 coulombs. Those are kind of odd units, right? We usually see micro or we see nano. Milli, we've seen, I think that's the second time, I think that we've seen millicoulombs. Okay, so it's not like it's uncommon, but it's not as common as micro or nanocoulombs. And for sure, in the end, if it's not coulombs, we've got to convert it to coulombs. So we might as well do that right there. We got another one that's 1.2 meters. That's to the right, I guess, isn't it? So let's make that charge 2. Negative 3.00 times 10 to the minus 6 coulombs. Charge number 1 over here, it's negative. We'll make that 2.00 times 10 to the minus 3 coulombs, not 10 to the minus 6. Although I suspect, yes, I did, didn't I? I suspect, just testing you, that would be a relatively common mistake because we're so used to seeing microcoulombs. Yeah, I'm so used to seeing microcoulombs. I did it twice. Instead of putting 10 to the minus 3, I put 10 to the minus 6. So be very, very conscious of that, okay? We got to watch out for all these silly little things. Right? We've said this before. If we make a mistake on an exam, we want to make it a good one. Right? We want to make it a good mistake. We want to really mess it up. We don't want to make some silly mistake like that and lose a point because we made it 10 to the minus 6 instead of 10 to the minus 3. All right, we want to find, how far apart are these? 1.20 meters. We want to find a point somewhere in between where the net electric field equals 0. Now, we don't know that it's midway in between. In fact, we know that it won't be midway in between. We could say that it will be closer to charge 1 than it is to charge 2, because charge 2 is bigger, so it's going to have more of an effect than charge 1. It's going to have to be closer in order for the field caused by 1 to be the same as the field caused by 2. Let's say that the electric field caused by 1, at least the magnitude of it, will be equal to the electric field caused by 2. Right? If the net electric field is going to be 0, then these two fields have got to balance out. E1 is going to equal E2. Therefore, K Q1 over R squared, we'll call this R, by the way, the distance from charge 1, where that point X is located. KQ1 over R squared is equal to KQ2 over, well, we're not going to call that R squared anymore, are we? It's a distance squared, but the distance that we have here between the point X and charge 2 is what? It's not R, it's 1.2 minus R. Right, if this is R and this is 1.2, then this has got to be 1.2 minus R. Now, I see a tiny little shortcut here just to save me some math and some exponents and whatever, and you don't have to spot this, but I'm just noticing this, guys, that charge 2 is 1.5 times charge 1. You see that? So I'm just thinking here, save myself a little bit of bother. I'm going to write in 1.5 Q1 instead of Q2. Do you see why I can do that? Is that okay? I don't need to do that. Okay, I can put its value in, absolutely, put the value for Q1 and the value for Q2 in. The value of doing what I just did, though, is that Q1 ends up crossing off, canceling out. K ends up canceling out. And I'm left with 1 over r squared is equal to 1.5 over 1.2 minus r squared. So it just looks tidier if I'm not dealing with that 10 to the minus 3 exponent in there. Abby, question? Is that okay? Okay, if you don't like that, if you don't like what I just did, the whole 1.5 Q1, then leave Q1 over here and leave Q2 over here and plug the numbers in. This would become 2 times 10 to the minus 3 over 3 times 10 to the minus 3. Or sorry, equals 3 times 10 to the minus 3 over 1.2 minus r squared. You just got some extra exponents, that's all. All right, let's simplify this a little bit. Let's take the 1.2 minus r squared up by multiplying. Take this up by multiplying. We're left with 1.2 minus r squared times 1 equals 1.5 r squared. This one's easier than the other one was, the one we did the other day. We can square root both sides now. We end up with 1.2 minus r equals 1.5 r. Sorry, no, it's not 1.5 r. What's the square root of 1.5? We want to square root both sides, so make the square root of 1.5. We got that? 1.2247 r. Let's take this over by adding. We get 1.2 equals 2.2247 r, and then r is equal to 1.2 over 2.22. Is that about 0.6 or something like that? 0.5 something. Yeah, it's going to be less than 0.6 actually. 0.539. Thank you. We knew it was going to be less than 0.6 because we knew that point x was closer to charge 1 than it was to charge 2, and if it was more than 0.6, then it would have been the other way around. Does that make a little more sense than the other question, the force question did the other day? Okay. Part of it's because the math is a little bit easier in this question, but mostly it's because you're smarter than you were the other day. Things like this make more sense to you now.